Perfect. All right. Welcome, everyone, to today's CISR seminar. It's a great pleasure for me to introduce the speaker, Dr. Jess Smith. Jess is a senior cybersecurity research scientist, I should get that right, at PNNL, and she has worked across government and industry for a long time. She's very unique in the sense that she's got degrees from two of the institutions involved in CISR. She's got an undergrad degree and a master's in computer engineering from the University of Idaho, and got her PhD in computer science from Washington State University. And when I asked her, when we invited her to speak to CISR seminar, the first thing she said is, I want to do this live. I want to meet with the students. And I said, no, we don't do CISR seminars live. We do it virtually because we've kept people from different institutions, and our students are also in different departments, and so that's the way we have been carrying it. So it's a great pleasure to have Jess today, and she's also not a stranger to the CISR Institute in general. She was one of the panelists when we had the CISR Summer Workshop in 2024, and shared a great deal of wisdom in terms of cybersecurity career to students. And today's seminar will be on a topic that she has worked on for quite some time at PNNL, and still continues to be her research interest. And this is going to be building trust in a world that's untrustworthy. That was a nice title for me to talk about on LinkedIn. And I'm looking forward to that. And we would leave, Jess, if you can, some 5-10 minutes towards the end for students to ask. And there will be a link, students, you would get at the very end to let us know that you are here and give feedback. That survey, and James would put it up. And so even if you have a class to go to, make sure that you do that at the very end. I want to encourage you to do that. Other than that, I don't have anything else to add. Thank you very much, Jess, for taking the time to share with us, and go ahead and get started.
Will do. Thank you very much. And yeah, I'm really glad to be here with you guys today. I was looking forward to being there in person, but it's a little bit challenging to be at WSU and Montana State and UI and all of the other participants. So we'll make it work. My one request is if you have questions throughout this, I've got the chat up. Throw your questions in the chat. I will try and monitor that. Ask me questions as we go. If you save all your questions till the end, I will have forgotten totally what I said on slide 1 by the time we get to the end of this. So feel free to jump in. So building trust in an untrustworthy world. I'm going to start off just real quick. Let's see if I can get the slide. There we go. I do have my PhD, which I think maybe qualifies me more for being able to speak on mental illnesses, intense amounts of stubbornness, all of those fun things than actually anything technical. But PhD from Washington State University, bachelor's and master's from over at UI. I've been working at PNNL now for a decade, which I've loved because I get to work on all sorts of different problems across a whole bunch of different sponsors, working for Department of Energy, Department of Homeland Security, Department of Defense, all of them. But I've had previous experience at Schweitzer Engineering, MITRE back in DC, and then I actually interned at NASA, which was a great opportunity. That is a really powerful office with a really powerful mission and a teeny tiny little budget. So it was a great introduction into the realities of working for the government. I am actually physically located about 20 minutes north out of Pullman. If you want to come up here, we're out of the little town of Palouse, and I do have alpacas. This is my poodle pup and two of our girls just doing a little bit of nose kisses there. So my question to you guys, I'm going to start this off with some questions. Who do you trust? Who in your lives do you trust? You probably, I hope, got a grandma or, whoops, I've got an echo going there. All right, there we go. I hope you've got a grandmother, a figure like this in your life, somebody who's older, who's just the sweetest person on the planet, and they love you, and you would trust them with just about anything. You would trust them. You'd put $100 bill in front of them, no problem. But would you trust your grandmother or this person to make a good password? Would you trust them not to be too nice and give money to people that maybe they shouldn't? So yeah, we trust our grandmothers to a point in certain areas. Linemen. I might not trust a lineman if I stick $100 in front of them. I don't know him. He's a random stranger to me. But do I trust linemen, the people out there working for our power companies, to keep the power on? Yes. Do I trust them to be safe? Do I trust them to keep me safe by keeping that equipment up to date, well maintained, all that? Yes, I totally trust them with that. So it's a different type of trust. And then finally, this is actually Officer Joe Handley. He lives down the road from me. Um, I trust Joe I'd trust him with my life. I'm not sure I'd trust him with my beer. Knowing Joe, he'd put something in it. So again, I trust Officer Handley in some situations. I would trust my grandmother with my beer. I wouldn't trust Joe with my beer. I wouldn't trust my grandmother to be responsible for maintaining the critical infrastructure, whether it's up on the top of a pole or in a substation to maintain our critical infrastructure. But I would trust a lineman in that situation. So as we go through this, something to think about is trust is not a one and done thing. You don't just, okay, I trust them. I will trust them with everything. There's some granularity there. Similarly, PG&E, major power company down in the California area. Most people trust them to keep the power on. We're going to ignore the wildfire issue for right now. But most of us trust our power company, whether it's PG&E or Con Ed or Avista or BC Hydro or whoever it is. We trust that company with a lot of things. We trust them with the safety of our house, that they're not going to use the electric power lines to burn down things, or like our house, hopefully. We trust Google. We have to. We trust them with our data. We trust them with our email. We trust them with our pictures. Would I trust Google with the electric power in my house? I don't know. I think that would be an interesting discussion to have. Would I trust PG&E with all of the data that I have shared with Google? Again, maybe, maybe not. And then finally, Chase. Chase is my bank. Do I have to trust Chase to a certain degree? Yes. Chase has my money. Chase has my mortgage. Chase has my car loans. They've got all of that. So I have to trust Chase with my money. Would I trust Google with my money? In some ways I have because I've got Google Pay. But would I trust Chase with all of the data with my email that I've given to Google? Not really. Chase has this bad habit of sending me targeted ads. And if they had more of the information like what Google's got, they'd send me more targeted ads. So again, we have to trust each of these. I have to trust PG&E to keep the lights on. I have to trust Chase to keep my money secure. I have to trust Google to keep all my emails and all of my pictures secure. I trust them all, but I trust them all in different ways, with different amounts of trust, with different things. And that is something that we really, as we're thinking about how we go about our world, we've got to be thinking about. And I think a lot of us it's background noise. Of course I think about this. Of course I trust Chase with my money and Google with my pictures and not vice versa. But being intentional about that is something that we as cybersecurity professionals really need to take and be very specific about how we do that. Especially when we're talking about mission critical systems. Most of us, when we go out in the real world, we're going to be dealing with systems that are not just your cell phone or the little programmable light bulbs. We're going to be most of you guys are probably going to be dealing with whether it's power grid, whether it's a military system. Naval warships are always interesting because they are a giant system of all things. They're really interesting from a cybersecurity perspective because of the interconnectedness. But then again, so is a base. A military base is supplied by power, is supplied by local water, wastewater, is supplied by so many things. So these mission critical systems are what we're all going to be focusing on. And there's a difference here between a mission critical system and what I would call a traditional, more IT style system. If an IT system goes down, they lose dollars. If one of these mission critical systems goes down, very likely we lose lives. It really has a lot more weight. So when we think about traditional systems, the goal is just to say, does it do what it should do? Great, it's doing what it should do. The laptop is still working, the cell phone lets me make calls. Great. When we're talking about mission critical systems, it's really shifts to prove that it does what it should do. We can't just rely on the fact that it is doing what it should do. That's nice. We have to prove that it should do or that it is doing what it should do. We also have to prove that it is doing nothing more, that there's not some added functionality in there, a little back door that gets somebody into our systems. And then again, for mission critical systems, we have that no matter what happened or will happen. If we've been hacked, or if we're going to get hacked, if a hurricane came through, or if a hurricane is going to come through, it doesn't matter. Our systems have to stay up. Because when we're thinking about systems like this, and I love this example because it's got so much technology in it, and you think, oh, it's an airplane. No, no. This is a computer. This just happens to be a computer with wings. It's awesome. The problem is that our mission critical systems, we can't afford for a little hiccup. An IT system, okay, you got to reboot. I think the pilot might complain if you have to reboot the plane when he's 30,000 feet up. That might cause just some problems there. So these systems are of a different caliber. So what do we do about it? What great, we've got a great problem. What do we do about it? First thing is we got to talk the same language. So I'm going to back this up half a step here. 3 words. If you guys are coming out of cybersecurity, you should totally know confidentiality, integrity, and availability. These are the foundations of our world. I've heard people try and swap them out for different words or, okay, these are inaccurate. They keep coming back because they are still effective at describing and communicating what we need to communicate here. So confidentiality, and I'm going to apply these to supply chain specifically. When I'm worried about confidentiality in my supply chain, it's usually, can I keep information about it secret? The silly example here is the KFC, their spice packet mix. They keep that very secret because that's part of their crown jewels as a company. Now, KFC's secret sauce, maybe not national security. Uh, the details of the encryption system that we're using on our intercontinental ballistic missiles, our ICBMs, that might be a little bit more critical to keep confidential. Alternately, we think of supply chains as, oh, it ends with me. It doesn't. It keeps going. A supply chain goes on past you to the end of life of whatever that system is. So if we lose a drone over Afghanistan, what information did we just lose? What confidentiality did we just breach? So that is a major concern. Kind of the opposite side of the confidentiality coin is that availability coin. And a lot of this is traditional logistics. Can I get what I need when I need it? Just-in-time manufacturing, all of those different things that the business folks want to do to maximize profits, a lot of that fits into availability. And it still, though, is very relevant for all of our systems because if you can't get what you need when you need it, does it matter if it has a high integrity, if it has high confidentiality? If you can't get it, it's kind of irrelevant. So that is always something to concern. And then finally, the integrity piece. And this is where a lot of my personal research lies because it is more fitting into that security of the end device. Can I trust it? Is it doing what I need it to do? So is, can I ensure that all stages in my supply chain are performed correctly so that the end product is what is expected and nothing more? Can I trust that my cell phone is cell phone, that my pager is my pager and not a mini bomb? That it's funny, we can talk about this. One of the great examples with all of supply chain is food. Can I trust that my food has been safely and properly processed? That the hot dog that I just ate has nothing but animal product in it and the animal product that I expect to be in it. Can I trust that the canned goods are good? All of those food things apply. They're great examples, but what we apply, the basic supply chain rules that we apply to our food, we really should be applying to our electronics as well. So these are 3 terms. We're going to go circle back to these later. But I'll pause here. Does anybody have questions about anything I've thrown out at you guys thus far? Okay, not hearing anything, not seeing anything in the chat. Like I said, if you guys have questions as we go along, stop me. So now that you've got this, what's the foundational part of starting with security? It's to know what you've got. If you don't know what you've got, you can't secure it. And I love quotes. Socrates, to know thyself is the beginning of wisdom. Okay, well, let's know our systems. Where does that start? Well, let's start understanding what's in those systems. And this is where supply chain really comes out and shines is, okay, well, I've got a cell phone. What's in that cell phone? What are all the chips in that cell phone? Where did all those chips come from? Who made those chips? What about the software on those chips? All of those things, all of that is part of understanding our systems. And I hear people in the back of my head saying, well, Jess, this is a mission critical system. It's a military system. It's the power grid. There's no cell phones in that. You want to bet? I have seen so often people come into our critical systems with random cell phone, random laptop, random whatever, because they're focused on that availability part of getting the job done. Can I make sure that I can do what I need to do when I need to do it? And they aren't thinking about the integrity of, hang on a second, should I connect this into my larger system? Is this secure? Is this at the level I need it to be to trust it for the larger system? So cell phones, great example. We all have one. How far do you trust it? I wouldn't trust it. I trust my husband with my password, but maybe not anybody else. Um, but when you think about your cell phone, you keep it very secure. Who had your cell phone before you touched it? How many different people built that cell phone? How many different people had a hand in designing the chips, the boards, the software, all of that for your phone? That's part of the supply chain risk is we have to think about all of that complexity. And cell phones are actually fairly easy. This is an older motherboard, but on a motherboard, you have so much complexity, especially when you start looking at the motherboards behind like our servers. They are insane. All of the complexity, all of the potential there for something to go wrong. So know thyself, know what's in your systems, and don't just stop at the it's a device. It's a SEL 451. It's a Cisco router. That's nice. That doesn't actually tell you anything about the system. That's like saying, hey, I've got a classroom and there's a John and there's a Jane and there's a Jess and there's a Jacob. That tells you nothing about, okay, well, Jess is computer engineering. She's got this much experience. She's got this background. John over there, he wants to be a teacher. He's still in school. Jacob on the other side, you know what? He's actually coming back. He's a former CEO who wants to reclass. All of those pieces of information are critical to know about the person in the same way that there are a lot of critical things we need to know about what goes on in our devices. Just knowing that it's a computer, just knowing that it's a cell phone is not enough for truly understanding and enabling security in our systems. And then we think about, okay, well, devices, these are complex. The problem is we've got systems. Picture on the left is kind of a simplified view of what a basic power grid system might look like. And I mean extremely basic. This is something that we can use to describe things. But then on the right-hand side, what you've got there is the beginnings of an actual system. And each of these columns is there to represent a different substation. And there are power grid chunks, power grid operators, Avista, local for me, PG&E, some of those I mentioned earlier, where they will have hundreds to thousands of substations, all connected together, all talking to their control center, all sharing different resources. And you as a cyber researcher have to understand it all. Just knowing what's in our systems is a huge challenge. And that's without even going into the software. Because all of those hardware devices have how many different pieces of software on them? Well, you've got your BIOS, and then from your BIOS, usually you build up to your operating system. And then off of your operating system, you're going to have different apps. And that's not including if you have virtual machines or anything like that. All of this software is still on our systems. We have to know it, we have to trust it. And I know there's some things on here that you're thinking, okay, yeah, Mac, Microsoft, Firefox, those are probably going to be on my critical systems. Photoshop, you'll a little less likely to see. Are you going to see Spotify on critical systems? Yes, you will. Are you going to see Instagram on critical systems? Yes, you will. Are you going to see random gaming software on critical systems? Yes, you will. Because most people going into these systems aren't security professionals. They're there to get a job done. And when they're not getting the job done, hey, there's a computer here. It can do Instagram. I'm going to flip through my Instagram. It can play my music, so I'm going to load up Spotify. Those pieces of software will be out there. Um, I especially when they start getting to the point, I don't know what there was a recent news article where they managed to load Doom on another silly device, but they've gotten to the point where you can play Doom on printers and somebody's going to do it. So as security professionals, not only do we have to understand all the complexity of the physicality of our networks, of our systems, we've got to also understand what they're capable of, what they're set up to be doing, as well as what they potentially could be doing. And I assure you, the user will find ways to do. It always scares me, the amount of weird things I have found on systems where it's like, did you really think about that? So the next problem is, okay, now that you've got an understanding of what your system looks like, you have seen it all. Seeing isn't necessarily enough because just knowing, hey, I've got this doesn't necessarily fix the problem. You also have to understand. Now, sometimes this can be super obvious. We can see things like these devices, and I'm going to pause here. If you guys take a look, obviously we've got our fake and our real on the top left as an example. On that bottom right, throw in the chat. What do you guys see? If reference device on the left is our known good, what do you guys see that's different in sample one? And if you're in a group in a classroom or something, feel free to raise a hand, go off mute, and throw out some ideas. What do you guys see that would make you a little bit suspicious of sample number one? Ah, very nice, Zach. Yes, the font. The kerning is just a little bit off on this, and it's just especially if you look at the apostrophes in 78 and 82, you see it there. Yep, Freeman, the plastic molding, those dots, those are injection molding. And again, it may not be bad, but it's definitely different. And yet the spacing in here, spacing is off, the wording is off. It just it's a little bit off. And this is not to say that sample one is a fake. This could just be a different manufacturing plant. It could be just a new generation. We don't know. But so much of what we're looking for is, hey, this is different. Why is this different? Okay. Next one, software. We do the exact same thing with software. Um, if you guys were doing some basic inspections here and really understanding the system, not just seeing it, what would you see on this one that would give you just that little hang on a second here, something's wrong? Yep. I am seeing everybody's catching on Supremo, TeamViewer, GoToAssist. Those are actual legitimate software, but first of all, they're not Microsoft products, and or most of them aren't. And I would really doubt that Microsoft is going to offer to remotely access your computer to log in to help you install Windows. You have to pay for services like that. That right there is very suspicious. Um, and Isaiah, yes, you caught the one that caught my eye the first. It's not Microsoft Windows, it's Microsoft Windows. So all of these things are things that when we look at our computers, our systems, our networks, our water wastewater treatment plants, our chunks of the power grid, whatever that may be, all of that are things that we need to be using this same side type of introspective. Is this what it should be? Do I trust this? Not just, hey, oh look, something showed up in a Cisco box. It must be good. Yeah, let's take a look. Let's actually look into the product and make sure that it is what it should be. And we've actually seen a lot of this with the COVID disruptions. All of the different challenges in getting electronic components with COVID meant that people were going away from their known and trusted sources of software, of hardware, of anything, and buying it where they could because they had to get it. That let so many counterfeits into our systems. And most of the time, counterfeits, they're just lower quality and it's not a big deal. They're there for money. They're there because somebody wanted to make money. But that also does introduce the ability for backdoors, for adversaries to get in. All of that is possible too. So that's hardware and software, and we can break down some pretty easy examples of what you're looking for. Well, the problem is that systems are much harder. Whether that's because you've been handed a server room that is just an absolute disaster and you have no idea what you've got. You inherited this. Please tell me you didn't design this. If anybody in this room designed this, we need to have some talks. So sometimes systems can be a lot harder, whether you're understanding that physical and it's a giant disaster, or you're talking about a true multinational global network that has hundreds of thousands of users, that has hundreds of thousands of pieces of software and hardware, and some of it's managed and some of it's not. And you have to work with all of this to get it connected. Systems are much harder to both see and to understand. But as cybersecurity professionals, that's part of our job. So once we've got that, okay, so we know what we've got. We've worked towards understanding it. We're never going to get perfect understanding, but we've worked towards it. Then comes the real problem. Just understanding is not enough. We then have to manage that insanity. And one of the most common ways, that, especially if you're going DoD, is RMF. And this talks about controls a lot, but even if you just take out the controls, categorize, understand your system, figure out what you need to do, select your controls. What needs to be done to make this safer? Implement your controls. Do whatever it is that needs to be done to make it safer. Assess it. How did that work out? Because sometimes things don't go like we expected. Authorize is a DoD thing. That's a little bit more specific there. And then monitor. We can't stop watching this. We can't stop saying, hey, what's going on with my system? Who added a screwball new thing, added a new piece of software, decided they wanted to plug their cell phone in there. Maybe if it's a corporate thing, maybe you took on and bought another company, and now you've got to merge those two companies' systems. That's a nightmare. All of that monitoring, all of that ongoing. And this is a cycle. This has to be a cycle where we are continuously evaluating our system, trying to figure out where's our problems, what's our options for fixing them, what's the most cost-effective options for fixing them, because I assure you none of us have all of the money, all of the resources we want to do to be able to fix things. Implementing those, seeing how that works out, monitoring it, and then going back and saying again, hey, what's going on? This kind of continuous improvement is critical to making sure our systems are stable, our systems are resilient, our systems are secure. And as you think through this, you think, okay, well, my system, it doesn't change. Yeah, your system might not be changing. Maybe you didn't do any new firmware. Maybe you didn't do any new hardware. But I assure you that the adversaries, whether that's your kid in his basement just messing around on the internet to see what he can poke with, to a nation state adversary, they are not sitting still. They're trying new things. They're exploring things. They're creating new vulnerabilities. So all of that mandates that we have to be continuous in our understanding of our. Somebody muted me. I think someone keeps muting me. Can you guys
I
hear
don't
me?
know how. We can hear you now. I don't know how that happened, but I'm watching out on whoever might have done it. But you're good now. Go ahead.
Okay, where did you lose me?
No, we didn't lose you much, really. So you can pick
Okay,
up wherever. Yeah.
I'm beginning to wonder if this is actually a Teams problem. We had a major all of our staff at the lab, some 6,000 people, had to get together and meet this morning. We had a major event, and amusingly, that happened a couple of times. I don't know who it was. I don't know if it was Teams. I don't know if it was a person, but yeah, there was a lot of commentary going when our the lab director Steve Ashby got muted a couple of times. Maybe a little bit of chuckling.
Yeah.
So maybe it's just Teams. We'll go with it being Teams.
Yeah.
So
Let's go with that.
anyhow, so continuous improvement. This is a critical part of how we need to evaluate and continue monitoring our systems. The problem is that we are just human beings, and are going to be things that we miss. I am mortal. I am liable to fall. I am a human being. I'm not going to catch everything. And the problem is that in cybersecurity, a failure on our part can mean a loss of life. So what do? Find good tools, whether that's designing security. Defense in depth is a huge piece of this. And I know this is foundational. You think, oh, this is old hat. Most modern critical infrastructure control systems, maybe not most, but at least a good chunk of them are still flat networks. There is no segmentation. There is no firewall internal. There's nothing. So defense in depth is still something that we preach because it's not there. Same thing with endpoint security. If we can stick antivirus on it, great. Can you put antivirus on a relay? Maybe. Some of the new relays have got pretty advanced versions of either embedded Windows or something like SE Linux. But there's a lot of our systems you can't do endpoint security on. So how do you work around that? Network monitoring. This is critical from all perspectives. However, again, in critical infrastructure, there are limitations. Network monitoring slows down the network. If you're talking about a network that is controlling a power grid or that is controlling a weapons system, you can't slow it down. So SIEMs are critical, but we can't always use them. And then finally, analytics. AI is a tool. You're going to hear AI pushed as a magic tool. I'm old enough that I remember when they said encryption was the magic tool that was going to secure everything and we were all going to be solid and secure because bop, I'm hit it with the magic wand of encryption and it's going to be secure. I'm seeing the same thing right now come down with AI. AI is a tool. It's a very powerful tool. It's a very interesting tool, but it is a tool. We can use it to help defend. I assure you the adversaries are out there, our attackers are out there using AI, figuring out how to attack us too. So it goes both ways. So all of these are tools. All of these are options. The challenge is what is right for your system. If we're talking about a wastewater plant, that's one set of security. That's one set of tools. That's one set of things that I can do to design in. If I'm talking about my F-35, that's a different level of security. That's a different set of tools. That's a different design. So it's hard to give you guys specific tools and say, here, go do this. Because part of being a cybersecurity professional is understanding your environment, doing that seeing, doing that understanding, so that then you can find the right tool, that you can apply the right tool to make your system more secure. Recursive question here, though. You've already decided that you don't fully trust your system and you need these tools to help you monitor your system. But do you trust your tools? This is always the fun conversation we have when we're talking about, for example, software. Hey, I trust my software. Well, not really. Let's take what am I looking at? I'm looking at the Teams software right now. Okay, let's say I don't trust Teams, or I do trust Teams. Either way, what about the operating system that Teams runs in? Do I trust Windows? Do I trust the compiler that compiled the Teams software? Do I trust the compiler that compiled the compiler that compiled Teams software? Do I trust all of the libraries that have gone into Teams software? Do I trust all of the bits of code that somebody copy pasted off of Google or now out of AI tools? We're seeing a lot of AI being used for writing code. Do I trust all of that? So when we think of this from a supply chain perspective, it's okay, yeah, here's my mission. I have to accomplish this. I have to trust this. Do I trust all of the things that my critical system is built off of? And that includes humans, that includes software, that includes hardware. That's a huge array. And I was trying to find a good quote talking about the descent into madness, because at some point you have to trust. We talk about zero trust. You can't truly trust nothing. I have to trust that the house that I am standing in was built properly and will not fall down on my head. I have to trust at a certain degree that my local power company will get me the power that I need to run my computer to do this presentation. I have to trust that. I can't go out and inspect the lines, the power lines, and the substation, and the control center, and the generation. I can't do that. So we have to trust at a certain point. But where is that point? If you don't trust anything, you will go mad, because I don't think you can do that. If you don't trust gravity, you've got some serious challenges. So we as cybersecurity professionals, part of this is understanding when, where, and how to trust. And a big part of knowing when, where, and how to trust is what your acceptable level of risk is. In a lot of things, we are forced to use tools. and we have to accomplish something. We have to get across this chasm, whatever that is. Maybe, and I don't know. I got this rickety bridge going over. Is this the great deep pit to lava, or is this over a dry creek bed? I don't know. Determining that changes what our acceptable levels of risk are. Is this the bridge to Mount Doom, or is this going over a dry creek bed? Once we have an understanding of what our environment is, what our system is, what our threats are, then we can say, okay, well, over to Mount Doom here, I want precision German engineering. I want a bridge that is 100% solid. I'd really like to be roped into that bridge. On the other hand, for some systems, we can't have perfect security for everything. We don't have the money, we don't have the time, we don't have the human beings, we don't have the equipment. So let's find the things that, okay, you know what? If the bridge on the right collapses, I'm going to feel bad because our grandma is going to get a sprained ankle, but I've got to focus my resources where they are needed. So that all of that is kind of the concluding piece to this is as you go through this, as you're doing your evaluations, as you're seeing your system, you're understanding it, you're doing your continuous monitoring, you're doing your continuous mitigations there, keep in mind, where do I spend my hours? Bridge over tower or to the Mount Doom here, or bridge over the creek bed. Find the systems that matter. And that is something that you as the owner of that system have to do that nobody else can do for you. So we are about 10 minutes out. I'm going to pop this over to questions. And Chris, is it out of the question to make your own tools? You can make your own tools. If you get to the point where you're good enough to make your own operating system, you're making your own hardware, you're mining your own silicon, I will be really impressed. But that's the challenge is yes, you can make your own tools, but is it worth your time? Has somebody else already made a tool that does what you need to do so that you can be more efficient with your time? Where's your time best spent? So yes, make your own tools, but also be aware of that has a cost. There is an opportunity cost. There is your time. There's all that pieces that need to go into this. So opening this up, questions from anyone else? And if you want to unmute and just ask a question, please feel free to do so. Don't bother raising your hand. I'm trying to monitor screens here and can't quite see everything.
I'm unmuting myself to just echo what you just said, Jess. So I don't think we need people to raise their hands or necessarily use the chat. So go ahead and ask your questions. We've got a good 10 minutes to have a good conversation. So I encourage you to ask questions.
And if folks do wake up with a burning question in the middle of the night, you can't sleep because you're thinking about supply chain and security, you can also email me. That's always a good option. Question, would you consider AI to be unsafe? I don't think AI is unsafe. I don't think AI is safe. It's, to use a very crude example, AI in a lot of ways is like a gun. A gun can be used in good ways. It can be used to secure something. It can help protect us. It can be used for hunting. There's a range of good uses. There's a lot more potential bad uses, though. So, is AI good or bad? No, it's a tool. Can we use it for good things? Yes. Oh, yeah. I was using it as part of this presentation of, can I figure out a good way to illustrate the descent into madness with a computer generated image? So I was using it. It's a great tool. Can it also be used against us? Can it be used for misinformation? Can it be used to target different people for different things? To enable, to enable bad code, to enable people to be lazy. Yes, all of those are things that AI can be used for. AI is a tool. The other thing to think about when you're thinking about AI is where did AI come from? AI has been trained up on, if it's natural language processing, you're talking about the majority of the history of the human written word. If it's images, well, okay, well, are we talking about people who have been paid for their images? Are we stealing from artists? Are we stealing from authors? Are we, so there's some rights issues there. We've also got to think about what is this data? Is it valuable data or not? AI is a tool and suffers from the garbage in, garbage out problem. If you feed AI garbage, it will give you garbage. And that is not to, all of this is not to say don't use AI. It's to say understand it so that you understand the limitations and the benefits of that tool.
So just to piggyback on that question, Jess, and if you can comment on a thing that we usually say, including myself, when people who work both in terms of AI and security, that there is a two-way street between them. So you could use AI for security, and then you'd also be worrying about the security of AI and make those models correct. And so
Yes.
if you want to just add a few things on that, that would be great to hear your thoughts.
I think that's right there is the key part of it. And I sometimes will phrase it in terms of supply chain security because it makes people think about the breadth of what goes into AI and all of the breadth of what we use AI for. It's kind of it's an interesting spread of reality there. It's AI sucks in everything and then can be spit out to everything. That's a lovely mental image. I'm gonna have to work on that one. But no, I fully agree. It's we can use AI as a tool to increase our security. We should be using our tools though to also increase the security of our AI models, our sources that we're training AI up on. Um, there's a reason that if you just let AI run loose on the internet and train it up on something like Reddit, you get something that is extremely profane usually. So understanding and using security to train up good models, to train up good systems, I think is going to be a huge push over the next few years. I have to wonder if we're going to get to a point where there are um, different gradients, different certifications for different AI algorithms based on how they've been trained.
Mhm.
I don't know that. I think it'll be interesting to watch, though.
Hi, Jess. James Crabb here.
Hey, James.
I was wondering if you have a maybe a specific example from your research relating to something you investigated, like supply chain of like you were talking about earlier, hardware, software, and you found something evidence indicative that there was some untrustworthiness going on there.
Ooh, I've got one. I wonder if I don't think I had a slide in this deck, and I don't think I can pull it up quick enough. But we do hardware investigations. We create software and hardware bill of materials, SBOMs and HBOMs. A part of that is so that we can understand systems. Very rarely do we actually understand. We buy a device. We don't buy a device that has the full list of all of its components. HBOMs and SBOMs, the point of that is to document that. As we were going through and exploring a board, this goes into a safety instrumentation system. It's actually one of the control gear that we use in nuclear power generation. It's effectively the giant box that's supposed to save us all if the nuclear power plant starts to explode. And we were going through that and actually found a whole, I think we're up to about 20 or 30 different chips on that board that have all been resurfaced. They've all been blacktopped, which is where somebody will take and go through and just kind of scratch off the top layer of a chip where it says what it is and then print what they want on there. Most often, this is for rad hardened. A rad hardened chip, radiation hardened chip, is one that is designed with extra packaging around it to enable it to go into space, other environments where radiation is a threat. Radiation causes lots of problems with our chips. We'll need more hardening. Um, and we see a lot of times where people will scrape down that top surface and reprint the chip. So they'll take a normal chip and claim that it's rad hardened. There's no real way to test for that easily on Earth because the functionality is the same. It just doesn't have the added packaging. But then when we put it up into space, we start seeing failure rates that are significantly higher. So we actually saw that in this nuclear control system. Like I said, we're up to I think 20 or 30 chips. So it's got to have been an entire string of them that were used, where somebody has gone through, removed that top layer, and printed something different on that. And that most of the time is what we see. Counterfeits and counterfeits for the purposes of making money are probably the most common thing that we see. Security issues, hackers in there trying to create backdoors, that's a lot rarer. Counterfeits, people trying to make money, that's pretty common. Does that answer your question, James?
Yeah, that's very interesting. Thank you.
Mm-hmm.
Trying to monitor the chat if there is anybody who has got last minute question.
Don't see anybody.
It was super clear, so that's one of the indicators. So I wish this was like 2 hours, just frankly, and so you could keep talking for another 1 hour so I can listen more. That was how good it was, and I'm sure that things were clear enough, and people have taken home the message that the systems we live in are inherently untrustworthy, but we still have things to do, which I think that nice summary of with the circles was a great one. But we've got one question right there, so if you could address that.
Yep, I will wrap up this last question. Redundancy, something we echo in military systems is redundancy in our designs. Is that essential or is it too much work? I would say it is essential, especially when you're talking military systems, space systems. My question is, do you have true redundancy in those systems? And this is usually when we build in redundancy, we have, okay, well, I'm going to design a system and I have 2 chips. I have 2 sensors to do the same thing, to make sure they're double checking each other. The problem is a lot of the time we buy the same sensor. We buy 2 of them, which is great. But if you trace back and you're looking at mean time to failure, mean time between failure, all of your basic foundational engineering principles there, if you bought 2 devices, 2 sensors off of the manufacturing line, number 1 and number 2, probability is they're going to fail pretty close to the same time. They're built off of the same components. They've probably got the same weaknesses. From a security perspective, they're using the same code. If they get hacked, they're both going to get hacked. So is that truly redundancy for our critical systems if they're both vulnerable in the same ways? And I have seen systems where they will go through and create a duplicate where it is a completely different vendor, a completely different system. That is extremely expensive, both in time and equipment. So it's rarely done. But it's one of those things where we go, oh, I was using this system, it failed, and then my backup failed. And I'm like, well, yes, because standard physics still applies, even when we're talking about electronics. What are some ways to tell that a not very well-known site is safe, especially if it offers a helpful tool? Oof. Yeah, those small businesses. Uh, that's an extremely hard one. My usual answer is get a VM. Don't put it on your main system. Put it in a very tightly sandboxed VM. Load it up. Let it run for a little bit. Watch it. Do your own investigation of that tool. If you've got the skill set, throw it into Kali or Ghidra, or not Kali, Ghidra or IDA. There we go. Throw it into something that you can reverse engineer it and take a look at it. Those small companies, yeah, I don't have a good answer for you on that one. Yes, and also use a VPN if you can. There are lots of nice free VPNs out there. Be safe. We can't discount the value of some of those small companies and their good tools. However, be suspicious. It's one of those, if I buy food from Starbucks, I have a pretty high level of confidence it's going to be safe. It may not be great food, but it's safe food. Same thing with the McDonald's, any of your big companies. If I go to a mom and pop shop down here, the Greasy Spoon on the corner, and buy a burger from them, it may be a lot better. It could also be a lot worse. So again, go back to our food analogies. Treat it like you would a random food vendor on the street, and buyer beware. All right, we are at 1 o'clock, and I know that folks have got class. So thank you guys all very much. It's been a lot of fun talking with you.
Thank you very much, Jess, for taking time. This was so much enjoyable, and I hope we will get you back again in the summer workshop, or if your time allows, for Act 2 of this one. I really enjoyed it, and I know the students have learned a great deal. So thank you very much. And those of you who are still online and you have not completed your survey, make sure to do that. We will be back on another CISR seminar 2 weeks